Hi, my name is Sarah Kazemi, and in this video I will explain how I use Jess to create a sound collage. For this assignment, we had to create a sound collage made up of at least 5 sound clips. A consideration to keep in mind before creating the collage is that we should ensure that sound clips have the same sampling rate. Otherwise, you may wind up with some unintended effects, such as clips sounding too fast or too slow. Another consideration is to ensure that your clips have the same bit depth or bits per sample. Bit depth determines the number of unique values a sample can have. A sample's value corresponds to its amplitude, or how loud or quiet a sample is. Having clips that have the same bit depth ensures that the maximum and minimum possible values for amplitude are consistent across samples. Just a quick note about sampling rate. Since the range of human hearing is between 20 and 20,000 Hertz, and because the Nyquist theorem states that the sampling rate of a signal should be twice the highest frequency component of an analog signal, it's common to record at 44 kilohertz. This is what standard CDs use for a sampling rate. However, the clips I found were recorded at about 11 kilohertz. This is about a quarter of the sampling rate used on standard CD recordings. And they all had a bit depth of 8 bits per sample. This means that the maximum possible value any of my samples could have was 127. In planning my sound collage, I used the following steps. First, I wanted to blend a music clip with a movie quote from the film The Net, where Sandra Bullock says something about computers. Second, I needed to find the 2 locations that Sandra Bullock says computer in her movie quote because I wanted to replace her saying computer with 2 other people saying computer. Third, I wanted to identify 1 second before Sandra Bullock stopped talking so I could interrupt her with a 3rd quote. Fourth, I needed to isolate where Johnny Mnemonic and Captain Scott say computer in the clips that I had of them, so I could use those to replace where Sandra Bullock says computer. Fifth, I needed to isolate my clip of a computer talking to just the quote that says there was an error, because I was going to superimpose that on top of Sandra Bullock's speech just before she stops talking. This would give an effect of her being interrupted. In steps 6 through 8, I just needed to insert the 3 clips that I created into the locations of the original Sandra Bullock quote. And then finally, I would normalize the volume of the sound collage and then write it to file. Even though it was not a requirement to blend sounds so that you could hear both clips at once, I wanted to create this effect so that the entire collage would have background music. This was achieved through this function, which passes in 2 sound objects, sound 1 and sound 2, and then a starting index to start blending sound 2 into sound 1. The algorithm iterates through index values from the starting index that was passed in, and then continues until the last sample of sound 2 is reached. As long as we still have samples in sound 1, as long as we haven't reached the limit of the length of sound 1, we're going to go ahead and create a new sample, which is basically the average of the samples of sound 1 and sound 2 at the same index position. We then set the sample at that particular index in sound 1 to that new sample value, and then we return the resulting blended sound.
Computer, it's in the computer.
Next, I needed to identify where Sandra Bullock says computer in the movie quote. For this, I used the explore function to locate the start positions for both instances of computer. I didn't need to worry about the end samples of this utterance because I was simply going to replace Sandra Bullock saying computer with someone else saying computer, and the lengths were basically the same. Here you can see the first utterance of computer starts at sample 46,536. And then here you can see the second utterance of computer starts at sample 61,217. I also need to find where Bullock stops talking, since I want to interrupt her to insert a clip that says there was an error, 1 second before she finishes her quote. Bullock stops talking here, so to find 1 second before that, all I do is subtract 1 second, or 10,000 milliseconds, to find the sample index of 167,735. I took note of these starting positions in a chart, much like this one, to use in my implementation. Now I needed to clip 2 quotes of Johnny Mnemonic and Captain Scott to isolate them, both saying computer.
I want to get online. I need a computer.
Hello, computer.
I also used the explore function for this. This time I needed start and end positions to provide as arguments to the clip function written in a previous problem. For the clip of Johnny, the start position of computer was located at sample 35,113 and the end at 47,012. For the clip of Scotty, he started saying computer at sample 4,688 and ended at 10,224. I did the same thing to isolate there was an error.
There was an error generating the audio file.
This started at 0 and ended 1 second later at sample 10,000. Here's the table of the data I've collected so far in preparation for my implementation. Steps 6 through 8 will be taken care of in my make collage function. Then we'll normalize the volume and finally write to file. I first wanted to prepare my clips as named sound objects. So target here is the blend of the background song in the main clip of Sandra Bullock. Johnny is the clip of Johnny Mnemonic saying computer. Scotty is the clip of Scotty saying computer. And then error is the clip of the computer saying there was an error. Notice that these values that are being passed in come from the table that we created. So the first number that you see being passed in the second parameter location is the beginning of the sound clip of computer for Johnny and Scotty and the beginning of there was an error for error. So that's pulled straight from the chart that we created. So here's the starting values and here they are here, and those are all being passed to the start parameter in the clip function. Then you've got the end values here that are arguments here being passed to the end parameter, and that's straight from the table from earlier. I then stored each sound object I wanted to insert into the target sound in a dictionary. So here's my dictionary. The sound objects are here. They are the keys in the dictionary. And then the values are the locations where each sound should be copied into the target. So these are the numbers or the indices of the samples where each sound object should be copied into the target, which again is the blend of Sandra Bullock and the background music. Using a dictionary enabled me to just use a simple loop here on beginning on line 131 to iterate through each key in the dictionary. Each key is represented by sound here. And then as I iterated through each key in the dictionary, I could copy that sound object that was the key in the dictionary to the target, which again is the blend of Sandra Bullock and the background music. And the starting location is simply the value in the dictionary. So for each sound, we copy the sound to the target at the respective starting location. After calling the sound collage function, I also wanted to normalize the volume of the collage by calling max volume, which we created in a previous exercise. And then just a quick note about max volume. When we first created that function, we assumed that our files had a 16-bit depth, but recall that my clips all have a bit depth of 8 bits per sample. So because of this, the highest value was 127, so I had to adjust for that. And then finally, after normalizing the volume, I wrote my collage to a file.
Just think about it. Our whole world
computer.
In the
Computer.
everything. It's all right there. Everyone is stored, and there's like this little electronic shadow on each and every one of us, just begging for somebody to...
There was an error.